Hello, everybody. Welcome to the February 2022 Data Users Group meeting. Today, we have a good friend of the data services team here with us, Brad Averbach, who's with Facilities Planning and Management, and I'm sure he'll tell you more about his position. But we work really closely with Brad on anything related to public-facing campus maps, as well as the underlying spatial data infrastructure that WashU uses to manage many different systems. So Brad, welcome. Thanks for coming. And whenever you're ready, go ahead and share your screen and we can get going.
All right. Thank you. So my name is Brady Averbach. I've been with the university over 30 years. Been with facilities for 25 plus years, and during most of that time, I've been with IT, setting up IT systems in facilities. In about 2008, we started using GIS, and we've been doing that ever since. And so today I'm going to talk a little bit about how facilities uses GIS and what it really means to have an enterprise GIS. When you talk about GIS with the data services library folks, it's usually more about analytics. It's more about trying to figure out how you compare different spatial data sets. It's a little bit different in facilities in that most of the analytics happens with the people looking at the data, trying to determine whether something is close to something or whether it's valuable where it's at. And what we try and do is take our data sets and put them in a spatial context. So what do we do in facilities? Basically, we manage the campus infrastructure to support the mission of the university. That includes building buildings, maintaining utilities, trees, the grass, landscape, those kinds of things. How we use our GIS is we associate our infrastructure in a spatial context, right? We need to know where our utilities are buried. We need to know where rooms are inside of a building. We need to know where trees are, sidewalks, so that we can create projects and repair sidewalks and things like that. We collect and share our spatial information. So we've worked with other departments such as sustainability, emergency management, even the library, to help collect data, and we share it with those same entities, or we share it through the use of an online map. We worked with the library data services to create the online map, and Molly's been a huge help in getting the shuttle information and having real-time feeds for that data feed for the online map. Again, it's all about a living data set that has a spatial context to it, right? So one of the last things we do in how we use our GIS is we use it to automate the production of map-based products. If you've ever walked into a building and you've seen the evacuation maps, that's something that we produce. Again, Molly has helped us do some of the programming to automate that process. And we use the emergency management department to actually go out and collect the data through tools like ArcGIS Collector and through our online map system. We've created those tools for them to go out and walk a building, figure out where the fire extinguishers are, where the pull stations are, and then create evacuation route maps. They update all that information, and then we have a process that actually generates all the actual floor plans with all that data on it, so that they can print it out and put it in the buildings. So let's talk a little bit about what is Enterprise GIS. It's more of a process than a project. I kind of talked about, if you're going to learn GIS and take one of the classes through U College, you usually get a GIS project that you have to work on, right? It's about collecting data, kind of analyzing different data sets to figure out where you want to put something. In Enterprise GIS, it's more about a process. We keep adding data. We keep trying to make the data better by comparing data sets in a spatial context to see if this is accurate. So it's a never-ending tool, right? It's a feedback loop of data, again, that we use in a spatial context to make our data better and to make decisions. we deal with data life cycles, and it includes data management. We have integrations with systems that need space data. We feed a system called WashU that the emergency management folks use, so that they can figure out where things are happening on campus, incidents and safety related events. And then we also deal with, when you're talking about enterprise GIS, we have to focus on security and accessibility. And it's one of the things that when you talk about enterprise GIS versus, say, just dealing with a file geodatabase, with a file geodatabase, you really don't have to deal so much with the security of it. You either have full rights to it or you have read-only rights. But when you get into an enterprise GIS, I have users that need to update certain data sets, such as lighting or utilities, but I don't want them to edit the building data or the green space, landscape, or other types of data sets. So we have a whole security model that we have to set up when we talk about enterprise GIS. And usually that's handled through the either Oracle or SQL Server, the DBMS that we use as a tool to store all the data. So the other thing I want to talk about is, and I know this was kind of one of the key topics that Doris sent out about what we were going to talk about, because we were going to talk about survey data and we were going to talk about drone data inside of our GIS. Back in 2012, we decided we wanted to do a survey of campus. And it took us about 4 years to complete it. We did it in phases. And one of the nice things about the team here at Facilities is they understood the value of GIS and why getting a survey done in GIS was really important for us. Surveys aren't usually done in GIS. They're usually done in Civil 3D or some Autodesk product. And they're usually done by surveyors who have a very predefined role in format and how they deal with data. So we had some challenges when we were dealing with survey data. We had to find a company that would actually deal with GIS and didn't want to just do it in Civil 3D. And we found one by the name of Horner and Schifrin. They're a local company that we used, and we actually used them a couple of years before for a different project. And one of the key things that we had to negotiate was understanding grid versus ground. So when you deal with a real world coordinate system, it's ground based, right? It deals with the spheroids, and it's more attuned to real world conditions. But when we deal with our coordinate system, we use state plane, which is a grid coordinate system. Everything's flattened out to a grid plane. And there's conversion utilities out there that you can take from grid to ground and back and forth. But one of the things we had an issue with is when we would hand out this data to a contractor, an architect, engineer, whoever it was, they assumed that it was in ground coordinates and not grid, even though the document said that it was in grid. And so I had to have several conversations with them about, you just need to do the calculation, right? Because they thought all of our data was off and it was bad data, when it really wasn't bad data. It was just a miscommunication and a misunderstanding of how the data was stored. So through this survey, one of the nice things that we did is we established benchmarks for campus. And right now, I believe we have close to 12 benchmarks on campus, spread out all over campus. And those are the national benchmark monuments that are buried in the ground. They have their coordinates listed on them. And in 2016, we started a project that we built 5 buildings at a cost of over $300 million. It was on the east end part of campus. And one of the great things, and one of the reasons we did this survey, was so that when we started doing the planning, because we had an underground garage and we had all these buildings being built at the same time, we really needed high accuracy for where all the stuff was going. One of the great things about having the benchmarks, having them done in state plane, is that when McCarthy, who is a general contractor, tied everything to these benchmarks. So when they handed us the planning documents, they lined up exactly with our GIS data. We could bring the CAD drawing directly into GIS without having to georeference it. And what we found out, which was pretty cool was we started drawing our green space and sidewalks based off of this. And a couple years later, when we decided to get a drone in 2019 and we started doing aerial photography locally, it lined up exactly with what the planning document said. And we also know that the aerial imagery lined up because we had the survey data for the rest of campus, and we know that all the sidewalk lines lined up correctly. So we knew that it was pretty accurate. So that was really kind of cool test of having benchmarks and tying things to the benchmarks, and a good validation of what we were doing with our data sets, right? So we talked about getting surveyors to understand GIS data, because most surveyors don't understand GIS data. They've heard of it, they can spell it, but they don't really deal with GIS data, although they're starting to come around to it, right? And part of that is because when you already have an established workflow and there's money on the line, the last thing you want to do is kind of rewrite all your workflows, right? So I understand that, but the value of GIS is that it ties into so much more than just CAD drawings, which while you can use geometry and coordinates in a CAD file, it doesn't really care about it, right? You can go in there and mess around with it, and there's no validation of the coordinate system per se. And so again, the last point that I have there is using survey data to validate other data sets. And I'll show an example after I get done with these slides of how we use the survey data so that when we fly the drone, we're able to tie it in very accurately based on the manhole points that we use as ground control points to align everything. And then as a validation feature, after we process it, we put all the sidewalk lines down and they line up. They either line up or they don't, right? And we can test how accurate our data set is based on that, because we know that all the sidewalk line work was done from the survey. So when we do drone data in GIS, one of the things that we need to take into account is RTK, which stands for real-time kinematics, and our drone, which is a Matrix 210, has RTK capability. And generally RTK gets us down to about 3 inches of accuracy without having to do much else, as long as we get a good signal and that we get good RTK data during the whole flight. But we also use ground control points. And one of the reasons that ground control points are important is because it actually gets us down to about a 1/2 inch accuracy. And it also ties us into the vertical control system. Because RTK doesn't always, because of the processing software that we have, they have a limited number of vertical data sets that we can use as far as coordinate systems. So currently we're tied into Geoid 03, which is NAD 1983, I believe. And Pix4D, which we have, doesn't tie into that data set. So if we just use their vertical datum that they would use to process it, we'd be off by about 30 feet vertically. So when we use our survey data, it now ties it into the vertical datum of Geoid 03 that we used when we did our survey. And so we get really accurate vertical data, which again is probably in the 1 to 2 inch range, which for vertical is pretty good. And it's much more than what we need. If we were within 6 inches, that would probably be fine for what we need. So we generate Ortho Mosaics. And for those that you don't know what Ortho Mosaics is it's photogrammetry that's tied into real world coordinates, and it knows where it is, right? It's ortho rectified, and it's a mosaic of images. We currently fly 7 different areas to create our Ortho Mosaic of the Danforth campus. And that's governed by the time that we get to fly. We have about 30 minutes per battery set that we can fly. And so we kind of have an area that we can fly in 30 minutes, which is roughly about 30 acres. And then we fly each set, at different times of the day or whenever we need to. And we have to be careful that when we fly it, we make sure we fly it at similar times of the day because of the shadows and things like that. Or if we can get good days where we have a light overcast that really minimizes the shadows on the ground, we can fly longer and get more data. So out of this data set, we can also, through Pix4D, we can also generate contours, which is really helpful for when we do updates. One of the things we use this for, if you've ever gone past Forsyth and Big Bend, you would notice that we're replacing the softball field with AstroTurf, right? And so when they did that, one of the things they needed to know was how much of a slope there was to the field, because they really wanted to level it off, and they needed to know how much dirt and rock and things that they were going to need in order to build that up to make it flat and in a good playable surface. And so, even though we had done a survey, there had been some changes, so we could go out, fly the drone, and actually get a more up-to-date information about their contours, right? So, and as we do other things, we can have good, good updated information. The last thing that we do is we can actually generate 3D models. And I'll show also as part of my demonstration how we actually have a 3D model of campus that is currently in the web viewer through the scene viewer of our portal system, which also could be used in ArcGIS Online. So before I get into that, the presentation side of it, are there any questions about what I presented about Enterprise GIS?
Brad, I was just wondering, like, since you started using the drone a few years ago, what has been the biggest kind of lesson learned or gotcha? Like, I'm sure there's a lot, but what do you feel like you would have known going into starting to use that tool?
Um, just the time involved, and it, I would say, yeah, it's just the time involved in some of the. I don't know that it would have helped me knowing this going into it, because it's just, you need to learn it as you go, and I'm still learning more as I go. One of the surprising things is I thought that the students would have more privacy concerns, and most of the time when we're flying, they're waving at the drone, they think they're on camera, they think they're going to be part of a a movie, right? And I was a little surprised by that. And I thought that um, we would have more issues with having to wait to fly over people, but that really hasn't been an issue. The drone's pretty small. The people, when they walk on campus, even if it's pretty crowded, they're pretty spread out. The time where I've had the most issue with that is like in the fall or the spring, when they're doing campus tours, because then there's a large group of people moving all at once, and I've had to pause the drone before when I've done some aerial imagery, just to let the group go by. One, because I don't want to fly over them, but also I don't want them in the photos, right? I'd rather have clean imagery of what I'm trying to actually capture.
And maybe I missed it. I don't know if you mentioned anything about mishaps with the drone. Have you encountered any of those?
Not necessarily mishaps, but we actually had an issue, and it may be, we've had the drone for about 2.5 years. And so I just had a conversation with my boss this morning about it may be time to think about replacing it, right? And
Yeah.
We now have 2 drones, so we have a backup, right? We bought a smaller drone. The drone we have is a fairly large drone. It's an enterprise class drone. The drone itself was about 15 grand. And the
Wow.
cameras that we bought were pretty close to that as well, especially for the thermal side of things. It's definitely paid for itself. But we had an issue where we were flying at night to do some thermal, and my coworker was flying the drone, and the thing just kind of reset itself and kicked her. So the drone didn't drop out of the sky, didn't like have any adverse effects for the drone itself, but on the screen it just rebooted, the camera rebooted, and it went back to normally it's pointing straight down. It started facing level again. And so we just brought the drone back immediately. And, we've had some instances like that. And when I went back and checked the log files, it mentioned something about needing to reinsert the batteries. So my guess is that maybe one of the batteries, because it has 2 batteries, is that maybe one of the batteries wasn't seated properly, and it had made a disconnect and reconnected. Luckily, there's 2 batteries in there, so we didn't lose power to the drone.
Yeah.
So one of the nice things about having an Enterprise is that there's a lot of backup stuff.
Yeah.
But knock on wood, we haven't had any issues with the drone. And when you get into the Enterprise class drones, there's a lot of fail safes. And what I've told the people that I've taught to fly the drone is, if you ever think you're getting close to something, just let go of the sticks, because it'll just stop, right? I
Yeah.
mean, the thing, you almost have to want to try and crash it to have an issue, anything, right? And I was just amazed with the cost of the drone and what you can do with that there's no like forward facing camera. There's no that you don't get like the controller that we have, right? He's just got like a controller with no screen, and it's just like, wow, okay. For what they paid, that seems a little odd, but
Yeah.
um,
Well, I think I think he uses an iPad with it, right?
right.
I
But
mean, he's
I
got,
mean,
yeah.
yeah, so one of the nice things about our drone is that, it has the potential for 2 cameras, right? And so we always generally fly with 2 cameras unless we're doing mapping, because we have a camera face down, right? But like when we're flying thermal and we're looking around or doing something, we have one of the cameras always pointed at the ground. So we have, we know where we're at, right?
Yeah.
So we have some presence of where the drone's at, because sometimes when you're flying a drone, you can't really tell how far away it is. You think, oh, I'm over the building, and you're not even close, right? Or you're
Yeah.
way past, right? Because depth perception isn't good, because you don't have a good background behind you, and it's hard to perceive that. But when you have something and you can see that, you can see exactly where you're at. And so we know that if there's a crowd of people approaching, we can just park the drone over a building, so we don't have to worry about that.
I know you guys deal with a lot of data from different sources. And one of the aspects of Enterprise GIS that I don't work a lot with is, integration of data from various sources. And I know a lot on CAD conversions. And I think, has it become any easier to integrate data from the various, applications that you guys work with into the GIS?
Yes, it has, but that's been because we went through and cleaned up all of our data, right? And because of that, we came up with some standards, and that's what's really helped us, right? Is that we figured out what is it that we need to do to make this data compatible, going backwards and forwards, right? And that was probably the best thing to do. And we got a lot of support with that, of, hey, we need to be on Missouri State Plain. So if we get projects I don't know if you heard when I talked about the East End project and the fact that we set up benchmarks, and McCarthy, when they came in, they used those benchmarks to tie everything into State Plain. So when they gave us some planning documents, it showed, what the sidewalks and the green space and all that stuff were going to look like. We just put it in
Just lined right up.
ArcMap, and it was right there, right?
Yeah,
And then
nice.
a couple years later, when we started doing our drone work and we created, Ortho Mosaics, because we had the survey data for the rest of the campus, we knew that sidewalk data lined up, so that when we looked at the East End stuff, it lined up exactly, and it was pretty amazing that, without really going out and using a GPS to kind of take measurements, just from using the benchmarks and tying everything in the State Plain, it all just worked, right?
Yeah.
And so that was really cool, because we had taken the steps to kind of put all the precursors into place, right? And I think that's probably one of the biggest things about with Enterprise GIS is you take data sets, and then you put data sets in to really build more data sets, right? And not only do you build other data sets, but you also use those data sets to validate what you already have, right? And it becomes this nice feedback loop, where it becomes quickly evident when things are out of whack, right? When things aren't as accurate as you need to be, or they're not correct. And that's probably one of the biggest benefits of enterprise level GIS, of having all this stuff in the same coordinate system and, you know, to some data model.
Mm. Well, speaking about the data model, let me scratch an itch here. Do you have any documentation of your data model?
Yes and no. So yes, I have several, and not all of them probably up to date and accurate, but really document, because part of it is document what we have in the database, then document how those become services, and then how those become maps, right?
Yeah.
And one of the things that we really struggled with, and I wish Esri had a better way to deal with this, is trying to figure out what domains belong to what data sets, right?
Yeah.
Without going through each one, because you
Yeah.
can go to the data set and see what domains you're using in it, but you can't go to the domain and say, hey, what domains are now you could probably run queries in the SQL database on the back end and figure that out, because there are links to all that stuff. But there's not any easy way to note that through our catalog or through the software itself. So, and part of that is, in the reason for that documenting the data model was because when you start changing services, you need to understand if you got to go out and update a map with that service, or if it's just going to update automatically, right?
Yeah.
Because you may have just broken everything because of the one little change you made.
Yeah.
So
Brad, you
anything else?
had some demo, you had some stuff to show us?
Yes.
Great.
So this is our private portal instance that you need to be on the campus to get to, and it's secured through Whistle Key. But this is a good example of our aerial map that we have, and this was all shot with the drone. This is what we take 2 drone aerials, one with leaf on and one with leaf off. This is one with leaf off. And this is really nice because we get to see all of the landscape areas that we have access to, because we need to understand that. We can also go in here and I can turn on the drone aerials. And what just happened? There we go. I can turn on swipe, and then I can actually see when I have leaf on and when I have leaf off. And you can see that it all lines up nice and neatly, because it's all tied together to the same coordinate system. And we actually have our archived aerials. They're not cached. These 2 versions of the latest data set of leaf on and leaf off are cached. So they're fairly performative. They're pretty quick. But we can actually go in and actually look at individual roof tiles. So we could do a roof inspection using this data if we needed to. Again, you can see the individual bricks in the quad. That's how good our data is. You can kind of see in the summer, because of the intensity of light, things get a little muddled. You have a little more contrast when you have lower light levels in the wintertime. So sometimes you get better results on certain data sets with strong light. Sometimes you get it better in the wintertime. So again, that's one of the reasons we take it twice a year. But if I go here and I look at the base map data, you can see this is actually all of our line work. This is what I was talking about. You can see it lines up right exactly with the sidewalks. And that's how we do our data validation to make sure that you know, everything is scaled correctly, and it's located accurately. Because you can have it positioned somewhat correctly, but you still need the scale correctly. And that's what's nice about seeing that the sidewalk fits inside of both lines, right? Because you know that it's scaled correctly. It's not just shifted to one side, so it's positioned correctly, but it's also the right scale for things. So if you wanted to take measurements, the measurements would be fairly accurate.
Hey, Brad.
Sure.
Do you have any benchmarks any features for benchmarks that you could show us?
We do. And you know what? The thing is I know why you're asking that, because you've asked me that before. And
Yeah.
so I've actually gone out looking for them, but I think part of it is that I don't know if they've been ripped up or if they've been paved over.
Okay.
Because where they are, I don't think it is grass anymore. There's a couple that have been, and I think some of them are buried in piles of mulch where bushes are now, where they weren't before.
Yeah.
So let me go into survey control, and yeah, so this is my survey data.
Yeah, I mean, because Alex and I had looked for some during one of the days I was working with him, and all of the ones that I had found in the database, we couldn't find them on the ground.
Yeah, this one here is the easiest to find. This one right here.
Yeah, and that's one of the ones we looked for.
And you couldn't find it?
No, we couldn't find it. Yeah.
That one I found. I believe I found this one.
Okay,
right
we looked
outside
for
of
that one
Greenhall.
too. I think we thought we had found that one.
Okay.
And then we looked for one up near the Olympic rings.
Okay. This one, I don't know where it is. I think it got buried or probably
Okay.
chewed up.
Yeah.
This one, I can't remember if I found this one or not. I think I did. But again, it's buried in mulch. So
Okay.
if you look at the drone aerial, you kind of see where it's at. Yeah, it's buried in that bush somewhere.
Yeah. Yeah, it'd be really nice if we had a couple of good, strong benchmarks on campus that we could locate, because we could take students out there and stuff like that. That would be nice to have a couple of good ones, especially if we could locate them near the library.
Yeah. So in this web map, I can't actually change anything, but there's one here. Otherwise, I would make them bigger, right? So they'd be easier to see.
Yeah. I see it. Yeah.
So there's a disc there. And again, I think this used to be grass, but now it's been paved over. I know this one, there was one here that they said they were going to have to replace because they knew they were going to have to tear it up. But there's several on the South 40.
Okay.
I think there's two down here. There's one somewhere in the middle. That was down here. Yeah, there's one there.
Yeah.
Maybe it just wasn't showing up, but I thought there's, yeah, there it is, right there.
Yeah.
So I believe that's inside the fence. Because it's on our property. I don't know if I have fences on here, but we have utilities. We have all of our stuff. We have interior space. We have it configured for several different ways to look at it. We have the rooms for med school, Danforth. We have our assets, our air handlers and things like that that we use. Again, we talked about sustainability. We have sustainability things. One of the things that they look at is the landscape area. So for performative landscapes, meaning it soaks up the water and things like that.
Yeah.
And it's more natural to the area versus something that has to be watered a lot. So it's drought resistant, things like that. So we're getting close to our time. So let me show you one last thing. And so this is something that we generated from the drone aerials. Looks like it's taken a while to load, but this is a 3D rendering of campus. So it's a 3D model. And I don't know if it's because we're on the Zoom call or why it's not as quick. It should be pretty quick to load. But you can tilt it around. And Well, it's not the best model because we didn't spend any time doing circles around buildings, which would give you more information data to build a 3D. This is just strictly from the Ortho Mosaics. It gives you a pretty good model for having to push a button and have it generate it, right? Which for a resource strapped organization like us, when we're talking about this, that's pretty big to get this level of detail just by pushing a button after flying the drone. So, and we could take measurements and things like that. And again, the measurements here, because the model, the edges of things aren't as crisp and accurate, it's probably within a foot, which is pretty good for what we need. So,
hey, Brad, I'm sorry. Just since you mentioned measuring and once before also, I'm just wondering, like, how confident can you be in your measurements that you're taking in these web maps when they, I assume, after publishing are in Web Mercator as opposed to the state plane?
so the biggest problem with measurements is snapping, right? Because you don't generally have a line to snap to. So you're trying to guess at where the beginning and the end point are. That's really the biggest deterrent to accuracy. It's not where it's at locally,
The reference.
right? So because I just did a measurement a while back because they needed to measure something on the east end of campus, and I was off by about a half foot. But when I went back into ArcMap and actually snapped to the sidewalk lines, it was spot on 119 feet versus a 118.4. So when I went back and I was much more careful and zoomed in and said, okay, here's the edge, I actually got much closer to 119 feet. So I would say that the measurements are accurate. It's spot on to probably, like I said, within a half inch. But it's really about because, and it's just even like with drawing in the map version, right? Is I tell people don't do complex objects. You can draw a nice little box around it and then come back in ArcMap and actually add detail to it because you don't get the snapping and you don't get the fine control of drawing within the online map.
Cool. Did you have anything else?
Nope, that was it. That's the end of my
All
presentation.
right. Awesome. Well, that was really cool. And I loved hearing more about your process. I mean, I've always assumed that I'm very familiar with your process, but there's always new things that I learn after we talk. So I really appreciate it. And anybody else have any thoughts, questions?
Keep up the good work, Brad.
Yeah, thank you.
Thanks for
It's
coming to
really
visit
interesting.
us.
Yeah, you're doing a great job for the university.
Amen.
Thank you. You're welcome. It was a pleasure talking to you guys, and thanks for inviting me. It was fun putting this together and talking to you guys.
Thank you.
Awesome.
Bye.
Thanks. Take care, everyone.
See ya. Bye.